So I assigned a couple of videos. You know, there's a lot of videos out there, and when you focus in on a subject, you can find different people's take on it, and that's kind of interesting. And I found that there's things I can glean out of most of these videos, and then there's a few cases when I'm not exactly thrilled with the way that they've done their things, but still they go through things. Like, for example, the Learn Fusion 360 or Die Trying, you know, this guy is good at kind of showing you the basics and how to move things around, but I'm a little perplexed by some of his design methodology. I do like the fact that he uses parameters. The thing he didn't do in this particular lesson was really design in place. So he designed the bottom and the top of the box side by side. And I think his design intent is more geared on having an output for the 3D printer than really designing the way that you might normally design something like that. So I'm going to, first of all, ask if anybody had specific questions related to that video, something that perplexed you or you'd like to discuss in the group here.
I'd just like to confirm how you say the word that's spelled H-E-I-G-H-T. Apparently it's height, according to that guy.
What's wrong with that?
Maybe it's a regional thing.
It might be a regional thing. I'm not sure. Is that a Texas accent he's got?
I don't know, but it said so many times, and I kept thinking, no, where's the H? What are you talking about? Sorry to digress.
Well, then to make it fun, we had Lars at the end with a good Scandinavian accent. That was fun. So if nobody has any questions specific to that, I'm going to bomb through my approach to how to address that specific design, how I would do it. Let me just find Fusion 360 here, and then share screen. And this time I'm actually going to share my second desktop. So you'll see a few things behind there because every once in a while I want to refer to my browser. Okay, so is everybody seeing my screen?
Yes.
Yes, you're on.
Yes.
Okay, good. This is doing some weird things here. Okay, so what is happening here? Let's start a new project here. And the first thing I like to do when I start a new project, and some of the guys missed it, is give it a name, save it with the name. So this is going to be the box 2. And I'm going to create a sketch. Sorry, before I create the sketch, I'm going to do the parameters. So we want to do our top-down design approach and create our key parameters for the design. Now, there was a question last week about this favorites. So I examined what favorites was. Basically, if you have a complicated design and you have a ton of parameters, but you have a few that you want to find at the top of the page, you star them and they're favorites at the top. They are still only local. They are not global. And there was also a question last week about exporting the parameter table and importing it into a different design. And what I found was there is an extension that's out there. It's not one of the pay extensions, but it's an extension that you can find by Googling it and install it and be able to export the parameter table as a CSV file and then also import CSV files into your parameter table. So there is some sense of being able to do sort of family design and a top-down hierarchical parametric approach to a family of parts or a family of products. So in this case, we're going to start out with a couple of key parameters, and let's go with the height, and we'll go with 75 on the height, and let's say a width, and go 150 on the width, and the depth, maybe 120. Whoops, put that in the wrong place.
Wrong field.
And what else are we going to use? Let's think about this box. Well, let's say some fraction of it is the top and some fraction of it is the bottom. So we'll say bottom fraction. And that's going to be no units. And let's make it 2/3, 1/3. We're going to have a bunch related to the hinge as the other instructor did, but maybe we'll look at those later. Let's start with the box.
Hey, Tim,
Sure.
what's model parameters then? Is that if you import a model? It would.
No, model parameters are the ones that you create in a drawing or in a sketch. They'll show up here. I'll show you in a little bit. There's nothing there at the moment because we haven't created anything yet.
Do you mean as opposed to 3D, it's when you're doing sketches that they show up as model parameters?
Yeah, so if when we're doing a sketch, you put in a value, then it will show up under the model parameters. So I'll show you what I mean. So let's start here. We're going to create a first sketch, and we'll do it on the XY plane. And I mentioned I like to use the origin as a center for symmetry, so I can use the existing planes for symmetry. One of the reasons I like doing that is sometimes you build up a design where you're importing things. And if you have that center set up, say for example, you import a circuit board, if you use the same approach, then the center of the circuit board will go into the center of the housing, etc., which often works out well. But it's strictly a personal preference. So in this case, I'm going to create a rectangle from the center so that I'm using this snapping on the center point. And I'm going out here, and that is going to be depth. This parameter, I'm going to type in DE, get depth. Tab, this is going to be width. And that's my sketch.
Tim, quick question. When you were picking the parameters, I assume that you could have put one of those as so many inches. You didn't have to be consistent, always using the same units of measure.
That's correct. I'll show you that. Basically, if you go to parameters, when you create a new parameter, there's a unit pull down. So no units you can use for fractions and counts, but then you have millimeters, centimeters, meters, microns, feet, yard, miles, nautical miles, mils, and then different approaches to angles, and then a whole bunch of other kinds of parameters that might get used in analyses, things like that, in management of materials, etc.
But you could mix units. Like for width, you could have put that in inches.
Absolutely. So
in addition to having the others in millimeters.
Yeah. So for example, I could come in here. Let's change this one. Oh, we can't change it after the fact. That's interesting. We can change the value but not the units, it appears. We can change the name, but not the units. But yeah, we could create one here, and let's say we just call it lip for the sake of argument, and make it in inches, and say it's 3/4 of an inch. That's totally valid.
Okay, thank you.
You bet. Yeah, and I'll often do that when I'm working with assemblies and I have parts coming from different sources, and some of them may be metric and some of them might be in inches. So now I'm going to create an extrusion for my box, for the bottom of the box. So I'm going to extrude this. It was already selected. And so the distance is going to be height times, now what did I call it? Lid ratio, bottom fraction. But there's something I forgot to do here, which I have tried to always remember to do and told everybody to do, and that is always create a component first. So I'm going to create this new component, and this component's going to be called the base, and the parent is selected, and say okay. Now what I'm going to do is I'm going to drag this sketch into here, and now my sketch and body and everything are in here. So I pulled the sketch in, and since the body was a child to this sketch, it brought the body along into this part along with it. Now you look that I'm activated on the base, and my timeline has the sketch and the extrude. So even if we kind of forget a few things, there's lots of opportunity to come back and repair what we've done wrong. Now, I'm going to do my little trick of adding solid fillet. And I'll just grab these, whoops, not that. This edge, this edge, this edge, and we're going to say that could be, I don't know, 10 millimeters. And I'm going to say, okay. Now, we didn't control the outside radius of that fillet with the parameter. We did that on the fly. If we go back to the change parameter dialog box, we see now under model parameters, it says base because we have a base part that has some parameters. We can see the sketch. It has the dimensions, linear dimensions, which it arbitrarily assigns the values D5 and D6, but they're controlled by the expression width and the expression depth. The extrude is controlled by the expression we put in for height and the default taper angle of 0. The fillet here is D10, and it's that 10 millimeters. Now this is perfectly fine if we figure that we never really need to modify this fillet. We don't need to fully parameterize if that's a term, the full design. We can leave it like that. Or if we wanted to, we could say, we could create something new, call it outside round, and say that it's 8 millimeters. Okay, and then we can come down here in this dialog even and change this to outside round. Now when we go back here, this round, if we were going to edit it, we see that the value is outside round. So we can make the parametric relationships later. Next thing I'm going to do is I'm going to create the top, and you think about this. Do I want to create the top or do I want to finish the base? Maybe I'll finish the base. Remember from last week, I like using shell. So I grab shell. I grab this top surface, which means it's going to be removed. And I didn't define the thickness, did I? I don't think I did. So if I go for thickness, there's nothing there. So I'm just going to say 2 millimeters for now. But again, I'm going to say, you know what? I want that to be managed in the parameter table. So I'm going to come in here, and I'm going to add something called, whoops, keys, fingers on the right keys, thickness, and then I'm going to come down to this shell, and I'm going to change this value to thickness.
Tim, can you confirm that the shell created a thickness of 2 millimeters on all 4 walls and the base?
That's correct. So let's look at that with a measure. So if we measure from this surface, and I'm going to use the shift roll key to go to here and grab this surface, you'll see it measures 2 millimeters.
Great, thank you.
Welcome. Okay, so there's my rudimentary box. I want a lip along there, and so actually it's kind of narrow. It's kind of a thin wall for this size of box. So let's make it let's double the wall thickness. So I'm just going to come in here to thickness. Change this to 4. I'm going to try to change it to 4, but I'm going to do it in the correct field this time. And now I have 4 millimeter wall. So I'm just going to say the lip should be half the wall thickness. So let's create a sketch right on this top surface. And let's project this outer edge. And then let's do an offset. And we'll do that from this outer edge, but we'll do a chain selection so that we get the whole outside edge. We'll bring it in here, and you notice it's negative. And in the video, he was having trouble using the parameter, and I think it was because the value is negative to begin with, so it kind of does something weird here. So what we're going to do is we're going to go with that. We're going to say, whoops, we're going to say -2 first, but then I'm going to come back and edit this dimension. Oh, it still says -2. So I'm going to say minus thick. Why is it not? Because I'm not spelling thickness correct. Minus thickness divided by 2. And now we see the fx that tells us that, that this dimension is controlled by a function. And we'll finish the sketch. And we'll extrude this, zoom in, make sure we get the right profile. And we'll take this down. And again, I don't think that we had a parameter for that. So it's like, yeah, that's when we want a parameter because we're going to use it on both sides. So I'm going to go back to the parameter table, and maybe, actually, we didn't end up using this one. That was just for demonstrating something. So let's add a parameter that says lip. I want it to be millimeters, so I had to delete it. And let's go with 5. It doesn't need a huge overlap. And we'll come down again. We can either come down here and edit that in our extrude here. Minus lip. And there it is.
Hey, Tim,
Yep.
when you started this sequence, before you did the offset, you chose to do a project. Can you remind us what that step was in the process?
Yeah, very good point. So project takes geometry that exists in our solid model or in other sketches and projects it onto our sketch plane. Now, it doesn't have to be in plane. In some cases it is, in some cases it's not. So for example, I'm just going to go off on a bit of a tangent here because I think it's useful to know. Let's say I construct an offset plane from this surface here, and I project it up into space well above here. So if I look at the front view, you'll see that plane is there. Okay, so I create that plane there, and now I go to create a sketch using this plane. I can project geometry onto this plane from any existing geometry down below or above for that matter. But it will put that geometry into the sketch on the plane that I selected as the sketching plane. So if I go for my project and I pick, in this case, let's say I want to pick, let me find another edge here. What's it picking? Specified entity here. Now I selected just that one entity by doing specified entity. If I look at part of the body, let me grab this. And that's my projected geometry.
But what did you grab just then?
I grabbed the outside edge of the box. And you see it's created this projection on the elevated plane. So it's projected, basically it's projected the chain of edges that are consistent with this edge. So all the tangent chained edges there. Maybe not even necessarily tangent in this case, it's just the chain. And giving me that closed sketch on the plane up above.
So those two planes, one your chosen plane that you want to project, and the projected plane, they are always parallel and only parallel.
I don't believe so. Let's try. You should be able to project geometry onto the, it'll be in the parallel direction. So for example, if you have geometry on an inclined plane,
Yes.
you'll get it projected as it would be viewed perpendicular to your sketch plane.
Okay.
So for example, if it were a rectangle, the rectangle on the inclined plane would be larger than the projected plane on the sketch plane. Is that, or projected rectangle on sketch plane. You understand what I mean?
Yeah, I'm with you. Okay, thank you.
Yep, no, good question.
So when you did the projection originally, what were you projecting on? I wasn't really following that, I guess.
Yeah, it wasn't as clear because what happened was I was projecting on the same plane.
Okay.
So actually, let me do that a little bit differently to make it more obvious. Let's just back up to beyond this sketch. We'll skip that plane and we'll start right here. So in this case, I'm going to create a sketch, and I'm going to start on this plane here. Okay? And I'm going to project the geometry from the outer edge. Okay? So now when I look, you see the geometry is projected from here, but onto the plane defined by this surface.
You had two discrete things you chose. One was the elevation of the plane,
Correct.
the one that you're on right now, and the other one was the outer boundary that you were going to project onto that plane.
That's exactly correct.
That's why we have that acrylic lid right there.
Right.
Okay.
Right? So in this case, you know, I mean, there's 101 ways to model things like this, but this is kind of, I kind of follow the way my logic works in terms of defining the model, the part. So I'm now going to finish the sketch and extrude this profile. Now, Fusion does this interesting thing where it, even though we've got a single sketch, it doesn't take the whole sketch when it sees other things in plane like that. So we have to sometimes select all of them. Now, we wouldn't have to select all of them. We could just select the wall portion, extend the wall up, and then do a bottom on it, base on it. In fact, maybe I'll do that.
But when you were selecting, you were doing just simply the click with the shift key down and accumulating the bodies?
Don't even need the shift key. Don't need the shift key with Fusion. Fusion 360 likes to do single key selection. Okay. Now the height of this extrusion, this is the top, is going to be height times height times bracket 1 minus bottom fraction, right? So now, what did I do wrong? This is in the wrong part, right? Remember, I needed to create a new component. That component should be the top. And it's now active. Now I'm going to come over here and see if it's going to let me move that sketch into there. It did. And it moved the body along with it. So now top has what we just sketched.
Because otherwise it was just an unseparated extension of the first.
Correct. It was just another body inside the same component.
Got it.
But now it's a component inside of a component.
Yeah, now it's a body inside a separate component. Oh, you're right. This component is inside this component. Good catch. So what that tells us is it's treating this as a subassembly of base, and that's not really what we wanted. So let's drag this into the top assembly. Now it's a peer to the base. So these are the kinds of hierarchical and parent-child relationships we need to be careful of. And one of the things that Fusion 360 is actually easier than some other packages at fixing. So it's easy to do this sort of drag and drop reordering. It works well. Now, you do need to be careful about the time order in which you do things when you are using geometry from another part, because we're not finished designing the base and we're already using its geometry for the top. If we add features to the base, those features won't impact what was done to the top already because they're at a later point in the timeline. Now, if we go back and change the earlier features or the early parameters, then it will affect it. And it's sometimes a little tricky keeping that all straight. So normally I would have done the top as a block and shelled it out because I like shells, because I like to do all kinds of other, you know, fun stuff with shells. And have that incorporated in my part. But I did want to show you that. Now I'm going to turn the top off and activate the base. I'm going to show you something I would do. Now that I've created this other geometry, I want my box, top and bottom, to fit together easily. And one of the things that happens here is these are all vertical walls. There's not a lot of give and take. So there's a couple things we could do. One is we could put a little chamfer all the way along this edge, or we could actually angle this whole face in a little bit. And I prefer that approach. So that's something called a draft angle. And so we're going to pick a plane. This is a base plane or a ground plane from which the angle is measured. So a parting plane. The term parting comes from molding, because this is something you would typically do in molding or casting. Now for the faces, again, I've got tangent chain selected. Now I'm going to pick this face. And because the fillets make all these other faces tangent, I've collected the whole ring. Let me just spin that around, show you what I mean. So the whole edge around there is selected. And now, let me go back to my home position. I can give that an angle. I don't want it to be a real crazy angle, or I'm going to have a knife edge at the top. But 5 degrees sounds reasonable. Now what happens is, as my top is moving through a bit of an arc because of the hinge, when it closes, it's going to have a little bit of give right until it gets there. So that worked well. I'm going to turn off the base and turn on the top and activate the top. A couple of things that are missing, the actual top of the top. So let's try something here. Sometimes we can infer, if we're drawing something, we can infer profiles from the plane that would be the sketch plane. So let's see if we can't select this profile.
Hey, Tim, just a
Yes?
quick question about the way the logic of the application works. You didn't choose this component and start working on it. You turned off the visibility of the other component. Does it then fall to this one?
No, I had to discreetly do that. I can have the active component be hidden. Right now, the active component is hidden. Now, it ghosts it to me to let me know that that's actually the active component.
Okay, so you actually selected it and I simply didn't notice.
Correct, yeah. If I select up top, the top assembly, it's going to ghost the whole thing. But if I come down here and the base is off, then I'm just going to see this.
Got it, thanks.
Yeah, no problem. So now I'm going to, let me think about this. If I were going to use a surface here and extend it, Fusion 360 is actually smart enough that I can do something like just grabbing it. But in this case, I want to do the whole surface, whole top surface, which includes the hole in the middle here. So I'm actually going to have to create a sketch. I'll do create a sketch, and I'm going to use this surface here. And again, I'm going to use project. And of course, there are shortcut keys. I could use P, but I don't like to do that when teaching because it's less easy to see. So I'm going to select this geometry, and it's going to give me both circles, but that's okay. I could come in and delete it, but it's going to do this weird thing selecting it anyway. So I'm just going to say finish sketch. Now I'm going to create an extrusion. I'm going to grab this and this, and I'm going to extrude down. Now here's the interesting thing. I'm trying to add thickness, but because I'm going negative into the part, Fusion 360 jumped to the conclusion that I'm trying to do a cut. I'm not actually. I want it to join. And the distance is going to be a minus thickness.
So your top surface actually was from the plane you were working on into the model, as opposed to adding it on top, which sort of intuitively would have been what I thought you'd do.
You would think so, but the reason I did this is because I used the height parameter to drive the height of that first feature. And so now my overall height is going to be height plus thickness.
Oh, right. Got it.
I've done it that way. So this is my design intent to preserve the integrity of my parameter. Now if I activate the base, in this case, I have this gap here, which is the other part of the lip. And so what I'm going to do actually is hide the base again. I'm going to turn this guy over, and I'm going to create a sketch on this plane. I'm going to project from the outside, and I'm going to offset from the outside in, and that's going to be minus thickness, or sorry, minus lip. Minus lip. That's not.
That looks too big.
No, that's wrong. That's the wrong formula. Lip is the vertical lip. So this is going to be minus thickness divided by 2. We decided, right? Okay, and we'll finish the sketch. Let me just orbit this a little bit so we can see it. And now we're going to finish the sketch, create an extrusion, and this is going to be this outside surface, and we're going to go up, or in this direction, by the amount lip. And it's a join. And there we go. So now if we go back to our default, turn on the base, now we have the boxes closed.
Tim, were you going to do a taper on the upper lip as well, or did you just find that the bottom one was good enough?
No, I like putting one on the upper one as well. But what I wanted to do is, let's go back to our fun little section tool. Grab this face, go in and have a look. Now, when we look from the right, we look in there, we see this gap.
That's awesome.
Right? So now what we want to do is, our top is activated, yep. So I'm just going to say okay and save that analysis for later. And I'm going to modify this part with a draft. And the plane, I want to swing. I don't want to select this plane. because I don't want a sloppy gap. I'd get a sloppy gap, or I can select this plane here. And then when I select the faces to draft, I'm going to come in and grab this one right here. Again, it took the chain around there. My angle, I'm going to take 5 degrees. Or you know what? Maybe I'll make it 4 this time. Now when I look in there, yeah, I actually do have a little bit of an extra gap there. And it's good to put in little clearance gaps and tolerance gaps. Our 3D printers aren't that accurate, but that takes a little time, but I think most of us understand. Paul Porter in the demo did some of that, so I'll leave that for you to learn from him. And then same thing with the hinge. I'll let you look at how he did the hinge, because I'd like to finish this one, move on to the next one before it's too terribly late. But this is a bit of a different approach. I like the shell. I like to build things all in one place. And then later, you know, we can come to the base and export it as an STL if we want for 3D printing, rather than building them side by side and then exporting them to the printer. I didn't quite get the logic in building them side by side, unless it was because he's thinking about dropping them on the platen of the 3D printer.
So
Hey, Tim.
a question.
Yep.
If at this point you wanted to make this, say, half again as big, do you have to change both the top and the bottom, or how does that work?
So let's say if I've done the parameters correctly, and it's a really good question. One of the things we should always do is basically flex the design. So let's see what happens if I make the height 150. Okay,
Very
so
cool.
it went up. Let's make sure that we don't have an interference there. So we can do an interference check between this part and this part. Compute, no interference is detected. We can also turn on our analysis, come in here and look. Yep, it's still the way it's supposed to be.
Tim, could you define interference again?
Interference, good question. Interference is a technical term for when two parts are trying to occupy the same location in space at the same time.
Got it.
And so the problem with 3D modeling is we can create interferences that can't really happen in real life, and then our part won't assemble. So if we want a simple example, let me turn on the analysis, and then I'm going to come in here to parameters, and I'm going to come down to where we had, in the, looking for where I had thickness divided by 2. Let's look inside the, here. Let's say we did thickness times 5 divided by 6. Okay, now, oops, that was the wrong way. Now I have a big gap in there. Let's go to that weird parameter that we just had, and let's make this 1/3. Not 51/3, but 1/3. Now we have, you can see this part comes out here and this part comes in here. They don't fit. And so if we do the interference check between this part and this part, and we compute, well, that's odd. Why did it not detect the interference?
I think it only selected one of those.
Yeah, it only said one.
Yeah, okay, let's try that again. Inspect, interference, select this one. Include coincident faces, let's select this one. And then let's compute. And there it shows us interference in red.
Wow.
And it even computes the volume. Because there are times in design when you use interference, when you press fit something, for example.
Thank you, Tim. That was great.
Yeah, I love these questions because that's how we're learning. That we're taking a fairly basic part and we're learning some of the more interesting aspects of it because of the questions that people are asking. I think there was another question in there.
Yeah, I don't know if this is easy to answer or not. I'm a little confused as to when you say the thickness is like lip or top. Is that because it directly relates to your parameters and then you can tell your parameters what the value would be? Like, how
That's
does it
correct.
know? Sorry.
That's exactly it. So the thing about parameters is, sometimes something like thickness, height, and width aren't the best terms. It might be better to say something like, it might be good to rename this to be wall thickness, so that we know it's not a program parameter, it's a user parameter.
Hey, Tim, can you say back what her question was, please?
So the question was, why were we using thickness in multiple places? Where was thickness coming from? Why was it relevant? And why could we use it in multiple places? If I understood the question correct. Did I, Elizabeth?
You're muted.
She might have muted there. That's what I understood the question to be. So I think maybe she had been aware that thickness was one of our parameters rather than something the program gives us.
Or I guess a follow-up question then is, at some point you said the thickness was the lip, and so that talks back to this window, and it knows the lip is 5 millimeters. Okay, so I talked that through. So then if you weren't, I guess I'm confused as to if you can do it so that you can just put in 5 millimeters. Would you be able to change that in this location still, or no?
Yes, you are, and that's a convenient thing. You have to come into the model parameters and find it, because sometimes these are not visible, right? But for example, if you look at this taper angle on the extrude, the taper angle is 0 degrees. This is probably going to break something, but I'm going to put in 5 degrees, say okay, and see what happens. And actually 5 is, we probably just can't see it well enough. Let's make it 20 degrees. Oh, that's interesting. Oh, there it is. It's this taper. It's this protrusion. See that taper angle? That's what we were changing there. So yeah, that's one that we can do it at the parameter table. And it's a really good point because sometimes it's a bit of a pain to go back and find the sketch or the extrusion when we have a long timeline and edit it. Whereas if we come in here, we can maybe more easily deal with it. And then update the design.
Hey, Tim, is there any rule that is good to follow, such as instead of saying width and depth and height, we might say overall width or object width, just to distinguish the general term, which could have been width in so many different ways in an object, and the overall. I'm just curious if that's like a good principle to live by, or if it really doesn't make any difference.
It does make a difference. That's kind of a best practices thing. So usually early on, in teaching, I use these simple terms, but later I want terms that we're going to, oops, where did this press pull come from? That are going to be more readily recognized.
Okay, great. Thank you.
But the name itself has no meaning. I mean, this could be, Bob. Whatever.
It should not be Bob, Tim.
It should not be Bob. That would be bad practice. But the point being that you can name it anything, the program doesn't care. But yeah, overall height is a good one. Or height overall, that's an improvement. Agreed. So use parameter names that reflect your design intent and that are unambiguous. And a bunch of these are not. You're absolutely correct. So very good critique. I like that. Further questions on the box?
Yes, I have a question on the parameters. Is there any way to tell the parameter table to sort by name, for instance?
I do not believe there is. It's basically in chronological order. But the advantage is, there's a couple things you can do. One is, there was a question last week about favorites. So once we get down to where we have like a lot of parameters, we can make some favorite parameters, and then they're always right here at the top and easy to find. And then the other trick with parameters is when you're actually using them in a sketch, as you notice, you type 1 or 2 letters and it gives you the list of parameter names that include those letters you've typed. So it's to your advantage to actually use long names that are very descriptive, because it's pretty easy to find them with just a couple of keys and then select them. And it keeps the design intent, and it's better practice per Travis's point a bit ago. Okay, and I'm not sure if everybody was here when I brought it up, but there was a question also about, can we export the parameter table? And I haven't done it, but I did a Google search on it and found that there is an extension for Fusion 360, a free extension you can download and install that will allow you to export it as a CSV file, and also to import CSV files that are in proper format. Now, there were people complaining that the exported format wasn't actually valid as an import format. You had to massage it a bit, but that might have been an earlier version.
So when we are designing some of these things based upon parameters, do we need to know what kind of material we're going to be using? Because I would assume that draft on one item would be different if you use a different material but the same file, and because of expansion and contraction of material?
Draft, typically, yeah, you might find some materials that are going to stick onto a mold more than others, and so you might use different draft. That's kind of part of, in your design intent, having the engineering knowledge of your material to select, to use a draft angle that's great enough. You know, general rule is use as much draft angle as you can get away with without making your part
Unstable,
not meet your functionality or not look good.
Got it.
But in terms of things like, you know, obviously when you go to build a mold, you have to build in shrinkage. And the shrinkage depends very much on the material, but that's part of the later stage in tool design. So
Got it.
Generally, and there's different approaches to design too of molded and cast parts. When I was at Nokia, they used a package called SDRC Ideas at the time. And you kind of designed a tool when you designed the part. So you're kind of designing the mold almost to a point. And I've come from a different school where basically I design the part and then send the 3D model of the part to the tool maker, and they design the tool. Now I do draft checks and make sure that I'm aware of any complications in the tool, and are the lifters valid, and all that kind of thing. But it's up to the tool maker to design the actual nitty-gritties of the tool.
Based upon the materials that you're going to be using to make the component.
Correct, yeah.
Right.
So I'll specify, so there was that plastic part I showed 2 weeks ago. I specified that as a nylon 6/6 with 10% glass fiber fill. I don't know offhand what the shrinkage ratio is for that, but the mold maker does, and it's going to vary depending on if I've selected a very specific one, he'll pull the manufacturer's specs on it. In this case, I made a generic specification, and so the manufacturer will use material from his favorite supplier, and he knows how they run things, what temperatures they tend to, if they run hotter or colder than other people, faster or slower. There's other kind of tricks in what actually
manufacturing. Right. Got it. Thanks.
Yeah, it's a good question. So, okie dokie. Any more questions on this? Now, the next subject, the next subject we had discussed was was drawings. We had kind of gone through a bit of a drawing last week, and then I gave you two videos on making drawings. What I didn't like about the first one is that the table wasn't really designed using top-down principles. You didn't use any parameters. It kind of threw the table together quickly, but what he was demonstrating was how to create a drawing. And so I thought it was adequate for how to create the drawing. And then Lars in the third video gave a little more detail on automated drawings. There's not a whole lot of functionality. Drawings are fairly simple in Fusion 360. It's really just grasping the mentality that we're making 2D pictures. We're getting, I think, what AutoCAD might have used to call like a viewport of a model into a drawing. And then the dimensions that we use are, we can add dimensions to the drawing, and they're basically a 2D drawing to show somebody what the part is. They're not necessarily driving dimensions of the part itself. I don't believe in, I didn't actually test it, but I don't believe in Fusion 360 that we can drive changes to the part. In some CAD packages, we can. So I should actually have tested that before I say that, but I'll have a look at that. But usually in Fusion 360, we're going to modify things in the model space and then update the drawing to reflect that change. Now, if you went through the drawings, were there questions that came up that people curious about what we can and can't do in drawings? Or anything there that was confusing and raised questions?
Hey, Tim, I'm not sure that what I'm about to say is true, but I think the little numbers next to your links are an indication of how many people clicked on them.
Ah, okay.
And so you have an attendance of 17 and maybe 3 people who clicked through.
Okay.
So you may not be hearing questions because people may not have watched it.
Aha. Okay, I would encourage you to go through it, but keep in mind that when you see people model, they're making mistakes. You saw me leave things behind and then fix them up later. You'll see that in a lot of the online stuff. And that's really how you end up doing things, because even though we're doing top-down design, we're not always thinking of absolutely everything up front. And some of that we do on the fly, and we add that level of specification in as we go.
I have a question for you, Tim.
Sure.
I was trying to design something that was like 8 feet by 4 feet, and I think I kind of broke Fusion 360 because it was too big. Are there limits, or have you encountered that?
I haven't encountered that. There shouldn't really be. So let's try something here, and maybe it's a bit of the default. Okay, if you want to be like that, let's save this, and then Y.
Great file name there, Tim.
Yeah. Because we can actually go with feet, but let's do inches. Okay, and let's sketch something here. Let's do a rectangle from here to here, and I'm going to say that I'm going to use 20 feet, tab, and 40 feet. There's my sketch, and it should still work. There is something related to accuracy. There's a parameter called accuracy, and usually it's dimensionless, and so it is impacted by your units and your scale, and sometimes you might want to change that parameter. And I have to remember where in fact it was. Here it is, general precision. Oh no, that's just displaying. That's not what I was thinking of. Precision in a different CAD package meant something completely different in this case. So now let's extrude this guy, and we'll go up like 120 feet. So might have been something else that broke. Because,
yeah, I guess so. Because you didn't have a problem.
Yeah, you can do houses. I mean, one of the projects I keep meaning to do is just gradually model my house so that I can pretend I can afford new furniture and where it might go.
Tim, that's Blue Ad, Zama. I don't believe there's any physical size on it because they use it a lot for architecture. There's a lot of draftspeople who use it that way. But the one thing that I keep spreading around the users page is the Marble Machine X. And this Swedish band leader has designed this marble machine, and he actually broke Fusion and talked to them because he had so many parts. And I mean, I don't quote me, but it's something like 15,000 parts in this machine that he's designed. And he was actually had a conversation with Fusion, and they helped him resolve some of the parts into sub-assemblies so that he could actually continue drawing.
Yeah, large assembly management is where the lower cost hobbyist packages like this really fall down. So the high-end CAD packages will do large assembly management where you select a region or subassembly, and you're basically swapping out inactive areas that you're not focused on out of memory and out of use, so that you're not loading up RAM with stuff that you're not working on. So you have ways to use simplified representations of a complicated assembly and just work on those. Because yeah, if you're doing it, you can imagine if you're doing an aircraft, people do, aircraft are designed in CAD packages that are a little more complicated than this, but in some cases, they're down to the point that every rivet is represented in the CAD model. There's a lot of rivets on an aircraft. Maybe fewer nowadays as they're using adhesives, but there's a lot of parts.
Hey, Tim, can I ask you a kind of high-level beginner question?
Sure.
Over in the upper left-hand corner where you currently show design, we have a lot of other views into this package, and you can assume a little bit from the individual words or pair of words that are there, but can you put those words into the broadest of contexts of what this package does and maybe how one layer relates to the other?
Yeah, that's a good question, because there is a lot going on here. So design we're familiar with. That's what we're doing right now. So this is where we sketch and create bodies and components. We also can do things like do our assemblies and do joints and specify motion, movement. There's animation where we can create animations of assemblies. Things spin, things turn, they push each other around. And so we can, for instance,
if you had modeled a V8 engine, you might be able to watch the animation of it functioning?
Correct.
Okay.
Simulation is analysis. So if you look at this bicycle fork here, the colors represent most likely stress in this case. And so as you design parts, you do an analysis and the computer will calculate stress at different areas of your part based on the loads that you tell it it'll be subjected to. And then you can see where high stress is and you can iterate your design. And if you're iterating your design, there's a generative design workspace. I haven't played with this a whole lot yet, but it's part of top-down design in specifying what your objectives are up front. But there's also, I believe, some iterative approach in there. But there might be a link between generative design and simulation. The purpose of simulation is really to analyze the design and then iterate it to make it better. Find the weak area, strengthen the weak area, see how it's going to behave under certain things. And usually there's stress, there's temperature, there's what's called modal analysis or vibration. Those kinds of things that you can analyze using a simulation workspace. Manufacture, Mark introduced us to this a little bit last week. So this is where we do CNC, tool paths, 3D printer stuff, etc. And in the drawing package, we looked at a little bit last week as well. And those other videos looked at drawing. And, you know, some people probably won't use drawing, and that's perfectly fine. If your intent is you want to design parts and get parts and design things and then output to a CNC router or output to a 3D printer, you might never really need drawings. So if that's the case, don't worry about it. Some people want the drawings when you go to build something. If you're doing things like furniture, then it's useful to have the drawing there. Render is basically making photorealistic pictures of what you've modeled. And that's something we definitely want to do, because I think that's one of the great things of a tool like this.
This is how every Kickstarter campaign begins, right?
Yes, exactly. Make it look like you've got something real. Like this is, you know, these are all virtual things. And it looks photoreal. You put it out there. That's your Kickstarter image. And people look at it and assume it's real.
Right.
So it's smoke and mirrors.
I'm still waiting for several of those to arrive years later.
Me too.
That's the way it goes. I'm still waiting for my Tour to arrive, actually. So we'll see what happens with that. Any questions? Any more questions about interface? About anything that you've observed over the last week, including tonight? Okay, in that case, what I'm going to do is I'm going to look at this cracker platter. And I'm not going to do the whole thing, but I'm going to go through a couple of steps. And in particular, this groove is an extra complication, and it's not immediately obvious how to do it. So I'm not sure if you all had a chance to play with it or not, but I played with it a little bit and tried a couple different approaches to it. and thought about the pros and cons, and I'll discuss some of that. So the first thing I'm going to do, of course, is save my component. So this is cracker tray. Oops. That didn't happen. I meant to hit save cracker tray. And then I'm going to create a component, and that's going to be the tray base. And I'm going to create some parameters to define my tray. So I'm going to have create form. Where did that come from? Something odd happened there that I didn't mean to happen.
Hey, Tim, do you always design parametrically?
I don't always. If I'm doing something very simple and I don't anticipate that I'll be changing it and there's not a whole lot to be gained, I won't. But any part that has enough complication to say have 15 or 20 features, I find that it does save me time in the long run and reduces the errors I make if I define internal dimensions in terms of what's going on in the whole top-down design approach. It also does sort of force me to think the design through before I jump in and do the bottom-up thing.
So quick and dirty or disposable, you may not. But if it's something of consequence and complication, you will.
Correct.
Okay.
Okay, so let's create a user parameter here. And we're going to say tray width. And millimeters, I'm going to say, let's make it 150 millimeters. And I don't know why this is, somehow it's clicking through somewhere or something. Okay. And we're going to have tray depth. And let's make that 100. And I'm going to have a, let's call it base thickness. And let's go with 15 millimeters. What else is going to be relevant? If I look at the picture of my object, I think the diameter of this groove is going to be relevant.
Yeah.
So and I'm going to use it. The other rule, back to the question of using parameters, is if I know I'm going to use that parameter in more than one place, then I definitely want to do it. So that if I edit something, I don't have to go back and edit it in multiple places. So in this case, I'm going to say groove diameter. And I'm going to say 15 millimeters. There's something else.
Hey, Tim, when you said groove diameter, were you talking about the diameter of where the crackers will go, that trough?
Correct.
Or are you talking about the arc, which is there forming the outer edges of the actual tray?
I'm talking about the trough cross-sectional diameter, not.
Okay, got it, thank you.
Yeah, but that was a good point. Trough diameter is maybe a better name. What else?
Or cracker diameter.
Yeah, that's the functional requirement. Yeah, that's the top level. And actually, I like crackers significantly larger than 15 millimeters, I must say.
Ritz.
So I'm going to start with that. And I'm going to create my first sketch. And maybe as I create my sketch, I'll discover parameters, other parameters I want. So I'm going to sketch here, and I have some symmetry here I want to take advantage of. So I'm going to not use that one. I'm going to use the center rectangle. And I'm going to go like this. And I'm going to say that that dimension is going to be the tray depth times 0.6 for now. And I'm going to say that this is the tray width. Now I want to create an arc on there. So I'm going to do a 3-point arc. And I'm going to start this arc here. And I'm going to come over to here. And it's going to go up to there. Now,
Tim, were you just relying on snap to grid to get it to the same position on either side of your vertical axis there?
that's a really good point. I'm glad you brought that up, because in reality, I want to check and see if whether it snapped to the line or to the grid. You see, as I move this, that this point is staying on the line. So it actually snapped to the line.
But it looked as though you were intending for this arc to have its acme on the green axis.
I do want it to have its acme on the green axis, and that's not constrained yet.
Oh, so you're going to get to that. Okay, got it.
Yeah. So there's a couple of things I want here. One is, I said I want my origin to be my planes of symmetry. So what I'm going to do is I'm going to come up here and use the symmetry constraint. I'm going to grab this point and this point, and then, oh, come on. Why is it not?
You're trying to define the third point, which is the green axis?
There we go. Yeah, I hadn't selected the other part. So when I do that, it made it symmetric. So you want to grab the 2 points and then the line or plane that's going to give you the symmetry. Okay, and then another thing I'm going to do here is I'm going to create a mirror and grab this guy, and I'm going to mirror him using this line. So there's the mirror image. Now, I want to control this dimension. So I'm going to go to dimension, but before I select a dimension, in this case, because I'm dimensioning on arc, it gets a bit complicated. I'm going to right click, and I have the ability on arcs and circles to dimension from the center or the tangent. So I'm going to go from the tangent here. Whoops, I told it to go to the tangent. Why didn't it do that? Pick circle tangent, yeah, to this tangent. There they are. And I'm going to put it there, and that's going to be my tray depth.
Tim, I may be alone, and forgive me if I am, but I didn't exactly understand how that tangent, how you got the tangent to the two arcs established there. Okay,
yeah, it's tricky, and it's always a bit of a pain to actually do. So when you, let me just, often when you sketch dimension, when you go to an arc, so first of all, you pick an arc or a circle, you get, if it's an arc, you get a radius, if it's a circle, you get a diameter, and you can toggle between those two. Radius or diameter right here, right? But if you dimension, say I want to dimension from there to a line, I could pick this line. Now, by default, it's measuring from the center of the arc to this line. The center of the arc is down at the bottom. Center of the arc is right here. But that's not actually what I want to use to dimension in this case. I want to constrain the outside, the overall depth of the platter. So I'm going to redo that. And what I'm going to do, I'm going to dimension. Oops, I want to escape here. And I didn't want that. So I'm going to just delete it with the delete button. Let's try this again. So I'm going to grab this guy. I'm going to right click and I'm going to say pick circle arc tangent. So this is from the menu that comes up when you click the right mouse button. Remember, it's context sensitive. So because I'm on an arc, it gives me the arc and circle options.
Got it. Got it. And this is actually how you were able to get those two parts, which were the tops of the arcs. Is
right.
It was defined as the diameter, or
as a. Come on now. Why did it? What's it doing to me now? It's a little fussy. So, okay, let's dimension. We're going to pick arc tangent, and we're on arc tangent again. Let's grab this arc tangent, and now we have the two arc tangents. Usually you have to try 2 or 3, because it's a bit of a tricky one. You've got to try several times to get it.
Great, thank you.
Yeah. So now I have a shape. I'm not sure I like the shape, but I have a shape. I'm going to finish sketch, and I'm going to extrude this. I'm going to grab all the relevant parts, and I'm going to extend it up this way by, what do I call it, base thickness. And there it is. Now, if I look at this from the top, is that really the shape I want? Not quite. Let's mess with it. So what's wrong with it? Well, it needs to be wider for one thing, or not as tall. So let's go to our parameters. And let's kind of move it out of the way a little bit here. So,
hey, Tim, just out of curiosity, if you had wanted to, could you have imported the raster image in the background and iteratively with the parameters sort of tweaked until you saw the shape of your drawing match the shape of the background image that you imported?
yes, so that's a canvas, and that's, I want to cover that in an import lesson, which is.
Okay, great. I was just out of curiosity, thanks.
Yeah, it is. And it's a very useful tool. Not every, that's not something that I've used before I got to Fusion 360. It existed in more painful means in the package I was using. Okay, now there's a number of things we can do here. You know, obviously we can throw some fillets on these guys here and make it get closer to the shape we want. That could be parameter driven or not. We have a shape. I don't know what we want to do in the bottom of this, but I'm going to do something odd here. I'm going to create a sketch, profile sketch, and I'm going to come in here and I'm going to project this object here, So now I have some things here. Now I'm going to just go in here and I'm going to say align up to here, and then what am I going to do? I'm going to come in and I'm going to create a 3-point arc from here down to here, like this. And then I'm going to create a line down to here and here. Now, did I get what I wanted to get there? Not sure. Let's turn the body off. Nope, I'm missing a line. And is everything there that I'm expecting? Did I get a line here? I think I might have 2 lines there, but that's okay. And now what I'm going to do, I'm going to finish this sketch. I should take more time into that profile, but I want to just quickly demonstrate a feature. Let's turn the body back on so we can see the geometry. And let's create a sweep. And the profile is going to be this profile. And the path is going to be this chain, and this chain is going to go till it gets to a sharp edge. I want its orientation to be perpendicular. It's going to be a cut. I'm going to say OK, and guess what I got? I got my router profile along there. I want the same thing on the other side. You know me, I'm going to do a modify. It's not modify, it's under create, mirror of this feature about, oh, come on. That didn't give me the plane I wanted. Let's again turn the body off because it's in my way. This, okay. Turn the body back on. And I got my router profile on both sides.
But might that not be a router bit that does not exist?
I'm pretty sure the way I drew it, it does not exist.
Okay, okay, yeah, okay.
So I just want to demonstrate how you can use the swept feature. You can do a swept extrusion, or you can do a swept cut, in this case, a cut. And
Tim, could you have chosen all 4 sides and had the sweep be continuous?
that's a really good question. Let's go back before the mirror. So notice it's gone now. And I'm going to edit this feature. And one path selected, I'm going to select, I'm going to try and select another path here. And why is it not letting me do it?
Perhaps because it was a mirror feature, or no?
No, let's see here. Let's get rid of the mirror. We'll just delete it. I don't think that's it. And it might, sometimes Fusion 360 will let you.
How about the single path on top? Can you do something?
How's that?
The single path on top, is that?
Oh.
Path plus a guide rail. This is for orienting as you go along the sweep. The guide rails and guide surfaces do a few other things. But yeah, I think you really can only do a single path in this case.
Well, when you chose path, though, I guess maybe you chose the one vector along the whole side that we currently see in red. You could not have chosen the similar baseline on the two ends and on the opposite side?
As an alternative, I could do this. Know what you mean? But then now my profile is doesn't make sense here.
Yeah, I was actually trying to say that original one plus the second and third and fourth.
Right. The only way that I'm aware of doing that is if I put a round here, a fillet here that's big enough for the router to go around the corner. Otherwise,
Okay.
I have to actually redefine it and do it here.
Okay, that's fine. Thank you.
Yeah, there is a way to use master profiles, master sketches, but we're not going to get to that tonight. But the one thing I did want to get to before too late here, and we're running a little on the late side, is this cracker groove. So does anybody have any ideas how you might do the cracker groove?
Yeah, Tim,
Yep.
I watched a YouTube video where they used the Cutaway Tool. The guy built a spear and then a sweep, and he put the spear inside the other body, and then it swept along and cut out whatever the tool was, and then the tool disappeared. Are you familiar with that process?
I haven't done that process on this package. I've done that process in other packages.
Yeah, I saw him do it on a YouTube video. I can't remember how he did it, but basically he created a ball, a sphere, whatever side he wanted. Then he put it into the other body, and then he picked one of these modify tools or something, and he built a sweep and he moved it through the body, and it cut out that territory.
Yeah, it might be. It almost sounds like it's.
I mean, can we at least agree that it sounds very cool?
It is very cool. It might be like combine tools. It sounds like a Boolean feature.
Yeah, I don't know enough about this stuff. I just remembered seeing it. I thought, oh, that'd be cool to learn.
Yeah, yeah. There's, one of the things we could do, obviously, if we look at this, let's go back to the picture. We could make a revolved cut with a circle that would get everything but the ends. But we'd have to define where the center point of that is. And we'd have to figure out the angle, and it would be kind of a iterative thing to get the angle that works.
Yeah. But I designed this in VCarve, not in Fusion. And I did just what you said. Basically, I set a molding profile into the top of what I'm building. And then followed that molding profile sweep. I built my own profile. And then on the edges, I took the half of that profile and I made a sweep around the circles on each end. And it carved it out of the wood. But it just took some experimenting on how to do that. I don't know if you could do the same thing in Fusion.
Yeah, what I want to think about when I do things like this is, one is how you define it mathematically, and the other is what's a really good way to control it, and what level of control do I need over this feature. So in this case, I want to control how wide this groove gets. I want to easily control it. I want to be able to visualize it as I'm doing it. And so the technique that I came up with involves a couple of steps. One is an offset plane, because the groove isn't a full hemisphere into the, if you extrude the sphere along, it's not half a sphere. It's less than half a sphere that's down in there, right? So the way I find it easiest to define that is to have an offset plane. I'm going to put a plane above this, and let's say it's at 5 millimeters. Okay, so now I have a plane. I'm going to create a sketch on this plane. And
I'm sorry, that plane was 5 millimeters above the surface, the top surface, correct?
That's correct. So if I look at it from the front, this is the plane here, 5 millimeters above.
Okay.
All right. Now I'm going to come up on top, and what I'm going to do is I'm going to do an offset, but I'm going to turn off my chain select. I'm going to grab, it's not going to work on that because it's a sketch curve it needs. So before I do that, I have to project. So first I project, and I do selection filter, so just the object that I've picked here. And Okay, it's projected. Projection link means it maintains this history of the relationship to this surface. If this is turned off, if I change the dimensions of everything else, this sketch is not going to update. But projection link keeps that link alive.
Hey, Tim, how is it that you chose just that portion of the curve? Is that an inflection point?
Yeah, so there's an inflection point. See, here's that fillet. So
Okay.
this is just the portion of the arc.
Got it.
So now I'm going to do an offset. And I'm going to offset this guy down this way. And let's say I bring him down, what do I want to do? I don't know. Let's say 12.5 for starters. Whoops, that should be a minus. Minus 12.5. And okay. Now this guy here, I actually want him to be construction, because I'm going to create an arc on top of it that I can control. So I have a start point there. Actually, I have a different technique here, thinking on the fly. I'm going to draw a line from here to here. And then I'm going to draw an arc, 3-point arc from this endpoint and this endpoint up to here. And what I'm going to do is I'm going to say that these two arcs need to be concentric. So, come on. Did I not get that? Concentric. This arc and the construction line are concentric. I guess I had already assumed that, so now it's over constrained. And I want to have a dimension on here, because I can change this dimension to 75. Now I can control how long the path is that I'm going to cut out. Okay, and I'm going to finish that sketch. Now, one thing I should be doing as I go along here is save, because some of these functions occasionally crash the computer. Although there is an auto save that works pretty well. Now, the next thing I'm going to do is I'm going to create another sketch.
Tim, all this last construction, that is on the plane that was 5 millimeters on the surface, above the surface, correct?
That's correct.
Okay.
So if I go like this, you can see it's there. And you know, I'm building some geometry as I go. So I'm going to go actually back to this sketch. Oops, what's going on here? Sketch, edit sketch. There's something else I'm going to need. I'm going to need a point right here. So I'm going to create a sketch point. And I want it to be right here at this point here. And it's the little triangle there tells me that it's at the midpoint of the arc. And that's what I wanted. Okay, so I'm going to finish that sketch. I'm going to create a new sketch. Oops, create a new sketch. And I'm going to make this new sketch on this plane of symmetry. And I'm going to create a circle. And I'm going to tell this to be the, what did I call it? Groove? No, trough. Trough diameter. And that's basically it. I'm going to finish my sketch. I'm going to come back here and say, create a sweep again. And I'm going to select, this is my profile, single path. I don't need chain selection. This is my path. And a cut. And now I have my groove. Right? Now, maybe that groove's too shallow, so I'm going to come back to this plane here. I'm going to edit the plane. Instead of 5, let's make that 3. Boom, now I have a deeper groove. Problem is, this part isn't great. There's a number of different things I could do here, and we're running a little bit late on time, so I'm just going to tell you what they are. One is I can figure out where to create a sphere using the create sphere, and it would basically be the end of the arc. So I could create a body sphere on, let's turn on this, this sketch here. Oops, that's the wrong sketch. This sketch here, and
would
now
the end of that line be the center of the sphere?
And
Tim, could you have, that's the sphere that guy used in the YouTube video.
yeah,
Could you have buried that sphere and run it across the sweep just like you did that circle?
I'm not exact. I haven't done that. It's possible. I'm gonna try and figure that out, because that would be a lot cleaner.
It just popped in my head when I saw you do this sweep, and then I saw you pick up that sphere.
Yeah, it's not letting me see the sketch when I do that, is it? Yeah, I need to put a sketch point on there to do that. The other thing I could do, quite simply, is I could, I do need to create, I'm gonna have to go back to this sketch here, whichever sketch has it. Oh, this sketch here is, so let me edit this sketch here. I'm stuck in the middle of some nonsense here. Okay, so I'm going to edit this sketch here because I think I need another sketch point.
You're adding the sketch point because just relying on the endpoint of that line didn't work when you were trying to position the sphere. So you went back and added a sketch point just to be able to grab it later?
That's correct.
Okay.
Now, the other thing I could do at this point, finish sketch. So I think I did this. I created a sphere, and I selected why am I not allowed to see that sketch when I do that? Somehow,
Tim, just to describe it to us, would you be placing the sphere of the same diameter that we had previously cut, and the center of the sphere would be at the end of that line, and
that's
then you
correct.
would do a cut?
And then would do a combine.
Combine.
But you do a Boolean operation, you do it as a subtraction.
Oh, got it. Okay, wow.
Use the sphere as a tool. And the other thing that can be done here too is what we can do is we can create, let's sketch on this surface right here, which now we can't see the body very well, so I'm going to spin it around, and I'm going to create a line. where am I going to create the line? I need the line on this plane. I need to create, before I do this, let me try something else here. Let me construct a line axis through two planes. And the two planes are going to be this plane and this plane. And it's not allowing me to do that. Because what, I did this the other night and now I'm missing a step. But basically, I had a line through the center and then I did a revolved cut.
Where you basically, that line across the top was your center axis of rotation?
Correct.
Wow. Okay. Wow. That's really cool.
That's how far I got, and I couldn't get to getting the ends rounded off.
Yeah, again, some of these plane creation doesn't look like it's quite as robust as I would have hoped. But actually, let me try something else on. So this sketch here is going nowhere. So let's, on this plane, that's what it was. Now I know. On this plane, I'm going to create a sketch. Come on this plane. Sketch, plane. That's weird. Oh, because the plane's not visible. Okay, so now let's try this again. We're going to sketch on this plane, and we're going to project this line. Okay, and we're going to create we're going to finish that sketch. We're going to create another sketch where we sketch on this plane. And now we create a circle on the midpoint here. And I'm going to go like this. I'm going to use a constraint of midpoint. So this guy gets locked to this midpoint of this. And then this diameter becomes the trough diameter. And then we draw a line across here to here. We make sure that these lines are coincident. And then we trim top part of the circle. And let's finish the sketch. Then let's revolve this profile about this axis 360 degrees. And we did something wrong.
It looked like the trough diameter was pretty large when you did that.
Let's edit the feature, see if we did anything. What did we do with wrong in the feature? One side cut, type angle. That's all okay. Even though we really only need to go 90 degrees.
Is it too deep, Tim? Is the plane down too far?
We were on the wrong plane, I think. Yeah.
Let's see.
Do a section.
But where was this? Okay, let's turn this plane back on. So that plane should be controlling, everything should be on the plane. And this sphere, what did it do to me now?
Made a smiley face.
There's something wrong with my sketch.
Is the plane at the same height as we originally used to create the trough?
It is, but you know what the difference is? No, that's diameter. Did I do the radius? No. So
It just looks like the diameter is too wide.
yeah, so let's go back to this sketch here. Oh, we are in this sketch. And let's delete this. And let's project. That's what we did. Project. Well, actually, in fact, wow. So we just have that line. That's really all we need at this point, I believe. So let's go finish sketch. Let's delete this feature. And what's this sketch here? What's going on with this sketch? So let's try this again. Let's revolve. This profile around this axis.
That did it.
That was it. Something got selected wrong there.
Previously you'd extended that line segment projection to be another line segment, the diameter of the trough.
To be the full circle, yeah. And somehow I had an error in there.
Got it.
I'm going to mirror this about. Again, sometimes they.
Tim, you're going to do this next part via a mirroring function?
Yeah. Mirror is just an easy way to do the same thing twice.
Travis is doubting you.
Well,
Travis has looked at a lot of mirrors and they don't work that way, but okay.
Based on the last 5 minutes, I'm doubting myself.
Whoa, that was fast.
Well, it was a little clunky getting there.
That's beautiful.
And the other thing, of course, that I want to do is change the appearance. And let's go do some wood. What kind of wood do we want here? That kind of looked like oak, didn't it? So when we do it here, this isn't rendering, but it does give us some idea of wood. Appearances and materials are something we want to look at in another lesson as well. When we specify physical materials, we're also including things like density, modulus, strengths, things like that, thermal behavior for the analysis simulation workspaces. But we can specify appearances and materials separately. So at this point, we changed the appearance to wood. We didn't change material to wood. The physical material, if we created this in a drawing right now, it would still say steel for the material because we didn't change the material. So there's a difference there, which we'll cover a little bit more in another lesson.
Hey, Tim, that was great. I tossed that challenge out there because this is something that we were trying to do in CNC for the holiday gift sale.
Mm-hmm.
And Rob went off and figured out how to do it inside of VCarve, and he's been cranking these things out. Rob, do you happen to have an image there that you could show people of what you did? I mean, I think it'd just be fun for you folks to see, because he's been working this, but from a different tool. Our design challenge is something you'd still like to continue in this, because boy, that was quite amazing to watch that happen. And I can imagine other people have ideas as well that they might want to see, well, how would you pull that off?
Yeah, yeah. And sometimes something looks simple and you come up with, you know what, it's not that simple to do. And then sometimes you overthink it and you make it way harder than it really is. But the thing I like about doing it as a design challenge is that I'm going to do 1 or 2 ways that I can think of, but I'm fully expecting 2 or 3 new suggestions to come out in the discussion, and that's how we all learn.
Yeah.
So I'm on my iPad. Let's see if I can figure out how to share the screen here. Share content. Am I ready? It says you cannot share the screen while others are sharing.
But Tim has to let it go first.
Okay. Share screen. All I can see is your screen, Cyrus. I mean, Travis. Share screen. Keeps wanting me to record something every time I do that. Let's see here. What do you see when you're looking? Do you see anything?
We just see the grid of people right now.
You just see the grid of people?
Yeah.
So, okay, well, that's what happens when I try to do this on my iPad instead of my laptop.
Yeah, I didn't mean to spring that on you, Rob. I just know you've worked really hard at it and you've been cranking them out. And it's just really cool that you figured out how to do that in VCarve. So it would just been fun for, I think, people to see it done a different way and yet to see even a final result. I think you've only done MDF versions, right?
Yes.
Yeah.
And I've got the drawing from VCarve that I could have shown, but like I said, it won't let me share my screen. It wants me to share photos or movies or something else. It doesn't work on my iPad very well. So it never even let me share it. So I'm not sure. You're probably just looking at everybody's, right?
Okay. It was just a thought. Sorry, Tim. Didn't mean to derail you there.
Tim, this is Dallas. I'd like to take a step back and just think through the workflow of what you've been doing. I've been just kind of making notes as I've been watching both the instructors that you recommended on YouTube and what you've been doing. And it looks to me like the sequence, there's some variation of this, but it looks like after you know what you want to design, you first open up Fusion and you save a project under a name. And then it looked like the next step was you were creating components, whatever components you were going to do. And then it looked like you were doing your parameters that you could identify early on. And then you did your base sketch. And then you went through a series of cycles where you would extrude and create 3D modeling, and then further sketches that would help further define each component until you got the component like you wanted to have it. And then after that, some things we're going to be learning about later about how you flex the model and simulate and print and so forth. We're learning. Is that kind of the basic sequence of things in the workflow?
That's a really good summary, Dallas. That's exactly it. I mean, you kind of, the idea of being top down is trying to do less of just design on the fly. There's a certain amount of that. There's iterative design. There's experimentation as you go. But you should have at least some idea in your head of what you're doing. And so you define the, oh, there it is. You define the object. You define the key parameters, the relationships that you see between the components in the project, and then your key base feature, which is usually a main sort of extrusion that is the bulk of the body, and then all the features that further define the body. And sometimes the sequence is obvious. Now, in this case, whether you did the inlay next or the groove, the trough next, isn't really that relevant. But for example, the ends, you need to deal with the ends before you make the revolved handles that go onto the ends. lines, you know, so there's some obvious sequencing there. But your description of the workflow, Dallas, is a really good one.
Hey, Rob, since we've got this on the screen, can you describe it a little bit, and especially what the piece on the left is relative to
The piece
the right?
on the left is basically, it's the inlay that's going to be like the dark wood, the walnut. I just grabbed the walnut from CRC. So if you look at it from this angle over here, you can see that it's raised. So it's a plug. And this plug then goes into this inlay, this V-carved inlay right here. So you just flip it over, glue it in there, and then you take a bandsaw, you cut it between the two, and then you sand it down so that it's nice and flush, so that there's no gap there.
And there's a taper on both the inlay and the inset, right?
Right there. Yeah, you guys probably can't see it that well from there, but basically it's a 90-degree taper. It's a 90-degree V-bit that's here, and this is all pocketed out. And then this part here, not as clear to see, is a taper the opposite way that matches exactly with this. You just flip the board over, and it'll go right in there and glue up.
And just high level, how did you create that trough? Was it that ball rolling process, or what did you do?
What's that?
How did you do the trough, just conceptually, high level?
I used a molding tool path, and I designed my own arch for the mold. As you know from discussions, it took several different angles. Basically, I used a 3-point arc for one side, and then for the other side for the end pieces, and swept it like he did in Fusion. And in the middle, I just had a U arc, and I set the diameter at what I wanted it to be, and then had it sweep through there. And basically, you remember the first attempt was I made it really deep, and then this, after you measured your crackers, I made it the right size of the crackers.
Yes, people, you heard that right. Part of the process here was I measured crackers.
So that's how it works.
Thank you, Rob.
I'm getting ready to carve it in some hardwood here to see if it really works as good as MDF. And I put the mortises on I put the tenons on the end so that one of the turners can actually turn something to go on there. And I think I can cut the mortise on my machine and not then Gary's willing to do them at the shop. And then they can turn them. You saw the other picture, which is what he's working from the challenge, right?
Yeah. That's great, Rob. Thank you.
One other thing that often happens when we think about, you know, these different ways, we've talked about the different ways to define things. And sometimes we get stuck in a mindset of how to create a feature. And maybe it's based on how we would actually build it, or maybe it's based on something like that. But sometimes we overcomplicate it. So while I was looking at what Rob did, I just realized that, you know, this is way easier than, I made this way tougher than I should have. So for example, let's create a sketch on this plane. And I'm just going to tip it down so I can see it. I'm going to project here and here. Oops, I didn't get my projection, did I? Project that and here. And okay. And then I'm going to draw a line from the midpoint here down, and I'm going to trim this, trim. These geometries don't want to trim, why not? Yeah, am I not? Oh, okay, I have what I need there. Okay, so I'm going to finish the sketch. Then I'm going to create my revolved cut. I'm going to grab this profile, and I'm going to use this as the axis. Right? You just think about it in different from a different angle. That was way easier.
Oh my gosh. Well done.
So sometimes it pays to go out and grab some crackers and measure them because it gives your brain a chance to come up with a different way to do things. Or go find a glass of scotch. I find that helps too.
Mark is with you on that.
But
Or
that's
the
about-
idea comes to you about 3 o'clock in the morning on how to do something.
It's not at all unusual, that's for sure.
That's right.
You're going out for a walk, you know, right now, about all we can do for recreation around my neighborhood is go for walks and cross the street every time you see somebody with a dog coming the other way. But it's a good time to sort of sort things out in your head.
Great.
It's all good, Tim. Thanks very much.
Okie doke. Any other questions? I've kept you kind of late tonight, later than I meant to.
It was great, Tim. Thank you very, very much.
Yeah, thanks, Tim.
Good stuff, guys.
See you next week.
We'll see you next week.
I'm
Thank
sure
you.
glad, sure glad they're videotaped.
Yeah, right.
I might have to edit that piece where I was fumbling around for 5 or 10 minutes.
Go
there.
for it, Tim.
No, I think it was good.
Bye-bye.
Have a
We'll
good
see
night.
ya. Good night.
See you Thursday.
Bye.